My circuits are buzzing for this one. It's time to talk about cracking. Our next speaker is Dustin Heywood, also known as EvilMog. He's a member of Team Hashcat and IBM X-Force Red, so you know this is going to be good. His talk is all about those protocols we thought were old, but are still haunting us. We're talking PPTP-VPN, MSCHAP-v2, and NTLMv1. I probably missed an acronym there. He's going to show us new tools and techniques to find vulnerabilities we didn't even know existed. Please give a massive welcome to Dustin Heywood.
Translator. All right, he's good to go. Perfect. Hi, everybody. I am EvilMog, and let's get on with this. So we're talking about NTLM version 1 to net NTLM reversion with the hashcat and NTLM multi-tool. Also added on MSCHAP-v2 because they're cryptographically equivalent, so you're gonna learn some fun things today. So, first bit about me. I'm a chief architect of X-Force, which is IBM's pen testing division. I collect black badges or free entry badges to conferences. I'm a retired member of Team Hashcat in that I haven't done the contest in 3 years, but I still do development, so I'm now retired. I'm a former sailplane pilot. I'm also a special effects pyrotechnician. I blow things up for a living. Bishop of the Church of Wi-Fi, and I play a lot of Hacker Jeopardy. But you're not here to talk about me, we're here to talk about MSCHAP-v2. So, first a little bit about Windows password storage, and yes, I'm sorry that black on yellow is terrible. But in Windows, you take a plain text password, you UTF-16 little endian encode it, and that's just MD4. And that creates the NT hash. Turns out this is the root of almost all evil to MSCHAP-v2 and NetNTLMv1, because the knowledge of that hash can be used to authenticate without actually knowing the password, which is handy with 128-character passwords. So, first off, some common Windows hash types you need to be aware of. Landman, or a very ancient DES-based authentication mechanism, hashcat mode 3000. The NT hash we were talking about was hashcat mode 1000. NTLM version 1 is 5500. This is a challenge response DES-based hash that can be reversed to NTLM. NTLMv2 does not have this vulnerability, and it's mode 5600. It's HMAC MD5 based. And then we have PPTP-VPN, which is a challenge response protocol used for authenticating to VPNs, and it is cryptographically equivalent to NTLM version 1, mode 5500. Then our favorite, MSCHAP-v2, is used to authenticate to WPA2 enterprise networks. And it, again, is the same thing as NetNTLMv1. Oddly enough, the MS stands for Microsoft, so go figure. Now, the NTLM version 1 response process looks something like this. Client sends a logon request, the server will send a challenge, the client sends a response. Now, this is very simplified, we'll get into details, but it's very similar to MSCHAP-v2. Client sets up an EAP MSCHAP-v2 tunnel, Radius sends a challenge, client sends a response. It's a little more nuanced, but you kind of get the gist. So the way NTLM version 1 works is the client sends a negotiate message. The server responds with a challenge message containing an 8-byte random number, aka the server challenge. The client then encrypts that server challenge with the NT hash as the key. That encrypted output gets known as the challenge response, is sent in an authenticate message packet. The server forwards that to the domain controller sends the results back. So I'm going to attack this. We can do some really cool things with it. So the client sends this NTLM version 1 SSP response. So basically, the 8-byte client challenge gets null padded out to 21 bytes. This becomes the landman response. There's an 8-byte server challenge combined with the 8-byte client challenge becomes the session nonce. You then MD5 the session nonce and truncate that to 8 bytes. This becomes the NTLM version 1 ESS hash. You UTF-16 little endian encode the password and MD4 it to get a 16-byte hash. That password hash is then null padded out to 21 bytes. These 21 bytes are split into 3 parts. Each part is effectively a DES key. The cool part about this is the third part of that des key is crackable instantly on CPU. And then you can crack these keys, or derive these keys basically via a chosen plaintext attack. So anyways, each part's converted to a des key. That des key is used to encrypt the NTLM version 1 ESS hash, resulting in 8 value bytes, and these 8-byte values are concatenated to form the NT response. Now with 802.1x authentication, similar thing, it uses a protocol called Radius. It works on wired, works on wireless, aka WPA2 Enterprise. If you've ever used NAC, you use 802.1x. It uses a shared secret to protect the client's challenge response. In this case, clients effectively are servers authenticating end users, and the end users authenticate with supplicants in response to 802.1x traffic. So the MSCHAP-v2, you have an authenticator 16-byte challenge, a client 16-byte challenge, the username, and then the challenge becomes a SHA-1 of the authenticator challenge, the client challenge, and the username. The password is the MD4 of the password, and then you have key 1, key 2, and key 3, and that equals a piece there, which I'll show you a bit later. And the recovery is basically just the des crack of those 3 keys. There's very similar resemblance to NTLM version 1. You have your challenge, you have your MD4 of the password, you have the 3 keys, and then your response is just des of those 3 keys. So the way MSCHAP-v2 works is your client sends a connection request. It sets up this outer tunnel. The outer tunnel basically is just TLS to protect the inner challenge response from attack. You can run what's called EAP MSCHAP-v2, which is without the outer tunnel, or you can run EAP PEEP, PEAP, which is the protected authentication protocol, and then you have an inner tunnel. So this inner tunnel, or the outer tunnel basically sets up, you send a connection request, server sends an EAP request, client sends accepts the certificate, sends the response. That sets up the outer tunnel. On the inner tunnel, the server sends an EAP request, or a request for identity effectively, to the inner tunnel to the client. That client then sends an EAP response identity via the inner tunnel to the server. The server sends the MSCHAP-v2 challenge to the client. Client computes the NT response, sends the response to the server. Server compares the NT response to the expected value. Then the server sends a success message with the authenticator response. The client then acknowledges, server sends the access request. This is a very verbose way of saying it's basically NTLM under the hood. It just looks slightly different. So an NTLM challenge response in Responder basically looks like this. You have the account, in this case, the domain controller hash that came to us from a Responder. And I'll back up a little bit. Responder is a tool attackers use to extract NTLM challenges over the wire. So what you can do is I can set up a listener effectively over layer 3 or layer 2, and then I can do either coerced authentication via things like petit potam, the printer bug, there's a DFS coerce. You can basically force machines to authenticate to you. And once they authenticate to you, you can then, because you control the server itself, you can then get them to send challenges. And if the landman compatibility level is low enough, you can extract the hashes. So I'm using this for a demo, but it's basically the same as MSCHAP-v2. So in this case, you'll see our DC1 is the account. We have a blank piece. There's always 2 colons. There's usually a domain name. In this case, it's EvilMog. We have our null padded landman response. We have the NT response and the results of the client challenge. So to crack this is kind of the gist of how the cracking happens. You'll see we take our password, we create our MD4 hash of the password, null pad it out. And there's basically encryption where we take those challenges we computed, and then we encrypt those with portions of the NTLM key, or the NTLM hash is the key. And that outputs a set of ciphertext. So reversing this, we just need to crack those 3 des keys with a known ciphertext, or known plaintext attack using hashcat mode 14,000, which is actually really cool. So here's an example with values filled in to show how the math works. I'm not going to dig into each one of these because this shows it a bit better, but this is with a real hash data. So the cool part about this is if you have a domain controller machine hash, those are 128 character passwords. You're never going to crack the password directly, but if we can reverse to an NT hash, we can authenticate to a domain controller and DC sync it. So to exploit this, you run responder. We tell it, responder attack I means, here's my interface, in this case, Ethernet 0. We tell it turn on proxy mode. You then force an authentication coercion via a tool called coercer. It can do the print spooler, EFS, DFS, etc. So you'll run coercer, coerce. You'll specify your attacker user, specify your password to force it to authenticate. You typically need a domain controller or regular domain user credential to do this. You specify your target domain, give it a target IP, and it will get you a hash we've here captured. You'll note here the challenge listed as this is the 11223344. That's the attacker challenge. Because we're using ESS, that challenge gets actually modified cryptographically, so you can't use it in, say, a rainbow table attack. So the victim challenge actually becomes this 933-801, et cetera, et cetera. Now, to exploit this, you'll download the NTLM version 1 multi-tool, and this is actually on a QR code later that I swear is not phishing. You're not paying me enough to phish you. You'll run Python 3 on the NTLM version 1 tool, give it the NTLM hash, and it will output the commands you type into hashcat. It's a little helper utility. So you can automate this whole piece. So you echo out to a hash file. You run hashcat mode 14,000, specify attack mode 3, which is the brute force mode. Tell it the des character set that we have built into hashcat, and then you specify your hash file and then give it a mask. You wait 72 hours with a pair of L40S GPUs. They're about equivalent to a 4090, and you rent them on IBM Cloud for about $4 or $5 an hour. You can get them cheaper on AWS, I believe. So what you'll do is you'll run hashcat on this, and once you've done that, you'll want to download hashcat-utils. Now, the results from this you're going to get are des keys with parity bits. You want to strip the parity bits. Thankfully, hashcat-utils has a des key to NTLM converter that will strip the parity bits. So you run your first portion, your second portion, and then you run the CT3 to NTLM.bin. The hashcat multi-tool will tell you what to go type in, and it will give you the 3 parts of the NTLM key. You combine those together, you're on the network. There we are, we've concatenated these values. You then netexec SMB to the domain controller, specify where the domain controller itself, give the hash. And because we're authenticating with the domain controller machine hash to another domain controller, it'll just give us the entire ntdds.dit file. This is how most hackers are getting into Active Directory domains if LAN-man compatibility level is set to 2 or lower. So you crack hashes, you get profit. That's not so interesting. The cool part is wireless attacks. Because NetNTLM and MSCHAP-v2 are cryptographically equivalent, you can use tools such as EAP Hammer or Host APD WPE or Host APD Mana. What these tools are, they basically create a fake access point. And they'll broadcast out, I am the Akihabara or whoever else is wireless. And then any enterprise environment or any enterprise clients that are out there, if they haven't checked the box saying, please verify the certificate, they'll authenticate. Now, the other cool thing is you can use certificates from, say, Let's Encrypt to make your Radius server trusted. And so by default, they'll just connect up unless they've said only trust this one particular certificate authority. So it'll give you a hash. It looks like this. I borrowed this from a friend of mine named Cosmo. So it gives you this output. It's Cosmo, K1, K2, K3 plus the challenge. It's all combined together. So if we can crack K1, K2, and K3, we have the MD4 of the user's password. Now, a little unknown thing with wireless, and this is the cool part. If you have the MD4 of the user's password, you can authenticate with just the hash and not the actual password itself to a WPA2 enterprise network. And then from there, you can then use that same hash against the domain controller, because most of these people running this environment are Windows shops. Unknown little thing, but it's super cool. And Linux clients natively support just the MD4 hash or the NTLM hash for the authentication. So the attack goes like this. Set up a rogue Radius server and access point. Offer up 802.1x authentication. You grab the challenge. Now, I released a new version of the NTLM1 multi-tool directly into hashcat-utils rather than integrating it into my existing tool. Now, it says use the hashcat format, but that's incorrect. my code is terrible, so it uses the John the Ripper format because I haven't fixed my parser. So you grab the John the Ripper version, which is this Cosmo Net NTLM version 1 tool. You clone down my hashcat-utils, and you run NTLMv1.py tac MSCHAP-v2. The output will look like this. So I'll show, here's the challenge. Here's ciphertext 1, ciphertext 2, ciphertext 3, and the last portion of the NTLM key is known as PT3. It will then output to crack with hashcat, create a file with the following contents, and you can copy and paste to create that content. From there, we run hashcat mode 14,000 again, using attack mode 3, specify a hex character set, 14,000 hash, and 1, 2, 3, 4, 5, 6, 7, and I believe it's what? 1, 2, 3, 4, 5, 6, 7, 8 characters on the brute force, and then we go ahead and crack. Now, typically on like a laptop, this will take 30 days. On 85080s, it will take you 7 days. With enough GPUs chained together, you can do skip and limit to reduce this key space. So for about $300 in cloud time, you can then crack this and get the actual hash out. So with the wonders of time travel, we've now cracked this hash. So you then take this output. You'll see here we have a hex 8923. These are, again, the actual DES keys. So we respin up the NTLM version 1 multi-tool, specify MSCHAP-v2, give it the challenge, then you give it the key output from hashcat. Now, this tool is not smart enough to determine which one's key 1 and key 2, so if it gives you no results under PT2 and PT1, just reverse the input into key 1 and key 2. It will then output your ciphertext 1, ciphertext 2, ciphertext 3, plaintext 1, plaintext 2, plaintext 3. Plaintext in this case means the NTLM fragments, or NT-hash fragments. Then it assembles them for you. So I have NTLM and the actual hash. And you'll notice the NTLM hash from this is the same from the the net NTLM crack we did earlier, because I used the password of password. And so I can recognize that NTLM hash a mile away. So again, here's how the tool is run. And you now have the hash, and you're now on the wireless network itself. Now, to grab the NTLM version 1 multi-tool for NTLM, here is the QR code. I swear to God, I'm not phishing you. Feel free to copy that. I mean, I could phish you, but it's not fun. And on that note, that was a whirlwind tour inside 15 minutes because, well, apparently I know this cold. So we have time for questions and to go over each piece individually if I went too fast. So, questions, comments, concerns, heckles, I'm open. Yes? No, it's single DES. Yeah, MSCHAP, the question was, does this only apply on 3 DES? So MSCHAP version 2, net NTLM, and PPTP-VPN all are the exact same protocol, and it relies on 3 individual DES keys, encrypting individual ciphertext. Let's get back to this. There we go. So basically, each one of these is an independent encryption operation rather than being chained. So they didn't do 3 DES. And the reason why they did this was because back in the 2000s, there was this thing called ITAR, International Traffic of Arms Regulations, and the US banned strong encryption. So this is Microsoft's response. And they got baked into protocols. Yes? And this is an ancient protocol that's in use today. So here's the thing. Every single wireless network you run on that's WPA2 Enterprise relies on this exact protocol. And it's single DES, not even triple DES. It's 3 independent single DES operations. Yeah, I mean, here's the thing. It's weaker than triple DES. The protocol doesn't support it. Any other questions? And please, I can go into this all day, so. No? Cool. Any other hashcat-related questions? Yes? You know, if you go to CERT-based Wi-Fi, this does not work at all. You have to steal certificates. Now, the thing is, in theory, this should not be possible if you're running PEEP, or EAP, PEEP, MSCHAP-v2 with certificate validation. But all it takes is one bad client configuration, someone manually connecting their iPod or whatever else, or say you've rolled your certificate authority, or even more importantly, if you have TLS enabled and clients validating asserts, but you haven't pruned down the approved certificate authorities list and still using default, let's encrypt's in there so I can just bypass the outer layer and go to MSCHAP-v2. Yes? Yes, printers do the same thing. They authenticate on NetNTLM1. There's also ICS/SCADA. A lot of old, say, centrifuges still run server 2003, which, here's the thing. NTLM version 2 has been supported since at least 2003. It was only NT4 and Windows 2000 that didn't have the later versions of it, but this protocol is still on our wires. And yeah, if it is not the NetNTLM version 1, which you should destroy, the fact that WPA2 Enterprise still has it as a standard, that means everyone authenticating with that protocol, which is about half the internet, is broken. Anybody else? I see Iceman in the back there staring intently. Do you have any good questions, sir? No, it was single DES. Yeah, it's 3 independent DES operations rather than being triple DESed. They implemented the protocol wrong. And so the RFC, they basically take the each portion of the hash, split it into 3 independent keys, run 3 independent known ciphertext attacks against them, as opposed to having them chained. Yeah, and that's why it's so broken. Yes? Yeah, absolutely. It's in 2 locations. The NTLM version 1 multi-tool is right here in my GitHub. The other tool is going to be, and in that GitHub repo, I have a walkthrough of how this demo executes. There's a whole steps piece in there along with some old slide decks. If any piece is unclear, hit me up. I'll upload this deck as well to it. And then the actual tool itself is in the new version that supports MSCHAP-v2. I integrated directly into hashcat-utils instead of my own private repo. That way, it could be carried on in case I get bored of this. Pardon, what was that question? No, we run a restricted DES character set that's specific to it, and that's going to be right. Where are we? There we go. See, DES full HCCR. We have a specific character set that ships with Hashcat now. Thank Adam for that one. I had to badger him for months to get that in there. Anybody else? And yes, you can heckle. I'm open for this. And general Hashcat questions are also supported. Cool. Oh, thank you all very much for listening to my rapid fire on this. And again, if you want the contents of this, you can track me down on Twitter, evil_mog, LinkedIn, EvilMog, Blue Sky at mog.evil.af, and yes, I do own the Afghanistan domain name for that, and this is not phishing. I may have had to break the odd sanction, allegedly. But yeah, hit me up. I'll send you the slide deck. Happy to answer questions. Please, please, please don't use MSCHAP-v2 or NTLM version 1 in production. That protocol is dead. Vinny. Also, I'll be at AV Tokyo running the Hashcat Sake Village, so if you are there, I'll be answering Hashcat questions while getting drunk on sake.